Okay. So yeah, we will start. So now what you have been doing so far in this course, like last two classes or three classes, we have been discussing about how to visualize data, right? So we discussed and we saw line plots, we saw histograms, we saw pie charts, right? We also saw some hexagonal plots, okay, hex bins, right? What more we saw? We saw joint plots, right? What are other things we saw? Density plots, right? Density plots, KDE density plots. We saw how those are helpful. Okay, we saw histograms, frequency binnings, like which occurrence is high in your data set, how many males are there, how many females. Okay, and you came to know also how to visualize something more than two dimensions. Okay, like you can use the size, the color as your extra dimensions to visualize higher dimensional data sets, right? How you can use bubble charts, right? Bubbles with different sizes where the size denotes one of the variable, numerical variables, and the color of the bubble might indicate your male or female or smoker or non-smoker, like that, different categories, right? So in that way, even though you are varying two different variables on the axis, there are two other variables you can simultaneously inherent in your plot based on the color and based on the size of your marker. Okay, size of your marker, okay, in your plots, right? So indirectly you can see we were visualizing four-dimensional objects in that case, right? Right. So after this, after you know how to visualize data, that is not enough. Just visualizing data is not enough. That's the key. Okay. I mean, you got a data set, you created a data set. Okay. Maybe if you're trying to work on a new project, you will create a data set. How you will create a data set? Most likely, I have seen biologists creating data sets. Right? How biologists create data set? Biologists, food scientists. I have seen in my university during my PhD, where I have seen a food scientist and biologist. They ask a survey. They just give a survey to the via mail to us. Everyone in the university gets a mail asking that, are you lactose intolerant? Okay. So you just have to fill a survey. Are you lactose intolerant? Yes, I am lactose intolerant. So I cannot drink milk, right? Or any milk based products. So what if you are lactose intolerant? What milk do you prefer? Almond milk, soy milk, oats milk? What milk do you prefer? Yes. So like that, they want to see out of 200 participants, how many are lactose tolerant, intolerant, and if they're lactose tolerant, which kind of milk they prefer. Okay. So if they want to set up a new cafeteria, they can keep this in mind. Okay. And start the cafeteria, right? So that they can attract a lot of customers from the university, right? If they keep only milk, then they will lose the customers who are lactose tolerant, right? So therefore, from a business perspective, this can be used, right? So you got a data set. Some of them made incomplete your questionnaire. So you have to clean the data set, right? You have to clean the missing values. You have to clean the data set. Data cleaning needs to be done. Okay. If there are a lot of variables, you have to, if you want to understand any insights, you have to do dimensionality reduction. For that, you have to do PCA, right? Or your discrete like pyramid algorithm, okay, data reduction, just to decompose and find the most important features out of many features, right? So after you did that, okay, you understood some parts of the data set you are working on, then you move to data visualization, right? So based on those two, which are the important variables, you draw a histogram. How many are lactose tolerant? How many are lactose intolerant? Those who are lactose tolerant, which kind of milk? How many people are drinking soy milk? How many people are drinking oats? Right? So those kind of distribution you will have. Now, is that enough? The answer is no. That is not enough. Okay. If you generate a chart, that is not enough. Just if you generate any visualization, I hope you might have encountered this in Python or anywhere without using Python also. Maybe many of you that you might have seen a plot in your class days or in science, any science discipline. Okay. And there is some curve like this. Okay. So what do you understand from this? Does this graph which I drew just right now gives you any information? It doesn't give any information. I mean, what is this curve? It starts from here and just oscillates and comes like this, but what is happening? I did not tell you what is x and y. I did not even give these numbers to you. The axis limits also I did not give. Okay. And I did not tell you what color are we plotting. Black means what? Why we are doing this line plot. So just showing the plot is not enough. You have to storytell about the plot. Okay, that's what the key concept lies in. You have to storytell the plot. Okay, any figure you get, you have to always explain the figure. Okay, explaining the figure. So I hope you might have done your bachelor's thesis, many of you, right? Or must have done a project in your bachelor's, right? Any subject. So when you have done, if you put a figure, you explain about that figure, isn't it? You always explain about that figure. Now, why you have to do that? You have to explain the figure because just putting the figure is not intuitive to the reader. Okay. So you have to understand the figure. You have to understand the figure. For that, you are explaining the figure. Now, explaining the figure is nothing but storytelling. Okay. You are storytelling about the figure. Okay. So these are some of the books where storytelling is given a lot of priority. Okay. Data visualization is important, but more than that, data storytelling is equally important, right? So you can see a storytelling with data. Okay. There are some plots here, but yeah, you can say it with charts. Say it with charts. These are the books, effective data storytelling. Okay. Anyway, so we'll see here. Okay. So it's one of the key skill in your academics or industry wherever you want to apply data analytics to. Okay. Whether in your projects or whether in your employment services in any industry. Okay. So this is the idea. So you can see this is what we are doing. These steps here is what we are doing since our first class. We took different data. Okay. We took different data sets. These are the disordered ones. Okay. What we did, we sorted them out. How many? Like now here they are mixed. Here they are mixed. No. Here they are mixed. What you do in the second step, you sort them out. I mean, which colors belongs to which. So you can see in each, they are sorted out now. Okay. They have been sorted out, right? Fine. Now it has been arranged, right? It has been arranged. Then it is presented visually. Can you see the difference between the first one and the fourth one? In the first one, if I would have asked you a question, which color cube is occurring more frequently, you could not have answered. Okay, because they are mixed. Okay, they are mixed. But however, in the fourth step, you can clearly see that yes, you can see that yes, this yellow and red are representing the most part of your cubes. Okay, while the black one is the least. Okay, black one is the least one representing. Any issues? Okay, so this is the idea. Okay, so this is just an idea to show you that how only plots doesn't help you. Okay, you have to storytell your data. You have to storytell your data, right? Fine. So we'll see there is another example here. Suppose you can see we are doing some kind of a plot here. We are doing, this is known as a stacked chart. Okay, stacked plot. Okay, so you can see nothing is clear. First of all, they are very close to each other. Each of the observation is very close to each other. And according to your Python setup or any programming setup, below each your vertical line, there has to be a label, numerical label, right? Now, since they are very close to each other, these numbers are also getting close to each other and are cluttered. Okay, these are cluttered, right? So therefore, the x-axis is not that clear. Okay. Therefore, the x-axis is not that clear. Okay, so what we have to do here, we could have given some label here and one label here in the middle and another at the end. That could have been helpful. That could have been helpful. But we understand that this plot gives us no idea what is happening here. Okay. What we are trying to do is we are trying to understand which web browser over the period of years has increased. How many users have started to use those web browsers? Okay. How many over the years has Chrome increased the number of users, or Safari has increased the number of users over the period of time? Okay. So this is not that much interpretable, right? But when you go to this line plot here, it is kind of visually intuitive, right? Why? Because you can see this is the market share, okay, on the y-axis from 0 to 70%, and you are running from 2010 to 2023. Okay, you are running your data set from 2010 to 2023, the limit on the x-axis. And what you are seeing here, Chrome has dominated. Okay, Chrome has dominated. But one other slight important result is, even though Chrome has been growing, Safari is going as well. Okay, even though Chrome is growing at a higher rate, of course, but Safari is also growing. Okay, Safari is also growing. You can see even the Chrome is growing, Safari is growing, while other web browsers have decreased. Other web browser share have decreased because Chrome is growing. But Safari is giving a good competition to the Chrome browser, right? So through this, we can understand the same plot. This same plot we can understand better in this example, okay? And how you see that without just showing the figure to you, I told you two important points. I story told you the data from this. Story told you about the figure here. I told you which one is dominating, that is Chrome. I even told you that even though Chrome is dominating, still Safari is increasing. Okay, its market share, right? So these are some of the ideas where storytelling gets more importance. Okay, so you have to explain what plot you got. Okay, just creating. So the idea is just creating a high quality or colorful plots is not enough unless it gives a good meaning to it. Okay, so that's all about the storytelling part. Okay, so this is the idea. Like many professionals make the mistake to focus too much on the facts and summaries in their communication instead of fleshing out the synthesis of their work. Okay? So these are the facts, like data points, raw information, unordered. Then we have to clean it and arrange it in a proper way, okay, to understand. Then we summarize them like organized fashion, condensed into facts. Okay, this is data telling. After that, you say that you focus on these implications, like so what, I mean, you gave me this plot, so what information it gives me. I know it can be very interesting plot. Okay, so I know it can be really appealing plot, very nice, colorful, high resolution plot. So always you ask, so what? Okay. So if you question a question like that, then you always keep your, what you call that, uh, level ready, that you are always trying to storytell your data. Okay. I mean, people almost forget this part. The third part people forget. Okay. So if you generate a plot, so what? Then you apply, yes, this is the plot, this is the line plot where it shows that Chrome has increased domination in the market share. Even though Chrome has dominated, Safari is still increasing its market share by 20%. Okay, so these are the implications I am giving from the plot. Okay, so this is what storytelling is. Okay. So this is all about, and I wanted to show you one small TED talk. Mm,
Which slice of pie is largest? Let's do a quick show of hands. Who thinks red is the largest slice? Any takers? Who thinks yellow? Couple of votes for yellow. Who thinks blue is the largest slice? Few votes. Any takers for green? Green is a popular choice. And what about purple? No votes for purple. And it's not purple. And one more choice. Who thinks they're all the same? Very popular. So the room is divided between yellow, green, and all the same. Let's visualize the exact same data as a simple bar chart. And now the answer is instantly obvious. Even if you had a hunch that it was green, how confident would you have been in saying which color comes second, third, and so on? The pie chart has failed us miserably. And this is far from the worst chart that's out there. I'm a data storytelling trainer, and I see bad charts everywhere. The world is full of charts that look like this. Maybe you see them in your workplace, or infographics meant to look fun and cute, like this. Or worse still, the creme de la creme of bad charts. I give you this. My vision for the future of us is a world in which no human being shall ever again have to suffer the indignity of trying to piece together a confusing abomination of a chart like this, decorated like a Christmas tree. Why am I so passionate about data visualization? And why should you care? Well, humanity is creating more data faster than ever. You've probably heard a bunch of hype about it. Slogans like, data is the new oil, or little factoids like, we create more data in a year now than in millennia of human history combined. And the thing about this hype is, it's actually justified. Data really is transforming our world. But data is useless unless human beings can interpret, analyze, and understand it and use it to drive action. To make sense of data, we need visualization. And for our visualizations to land and make an impact, they need to have a message that our audience cares about. In other words, we need to tell a story. I believe that data storytelling can change the world. The most impactful data stories can even save lives. Okay, so I know that's a big call. So I want to prove it to you. And today, I want to share with you 3 simple techniques that you can all use to tell compelling stories with data. You don't need any specialist expertise. You don't need to be a statistician or a data scientist to apply these principles. So 3 simple principles. The first is choose a human-friendly chart type. What do I mean by that? Well, let's take a look at an example. So we've got some data here from a personality test that I took and my friend took. And we want to compare our results across each of these 5 major personality dimensions. What do we think the differences are? Quite difficult to do with this pie chart. And we saw earlier with our little experiment that pie charts have some pretty severe limitations. And this is because with a pie chart, we're forced to decode angle and area. And human beings are much better at perceiving numbers that are encoded using simple bars, using simple length. So this experiment that I performed on you earlier is very similar to a series of experiments that was performed back in 1984 by 2 researchers named Cleveland and McGill. And Cleveland and McGill were fascinated by this question of which charts are human beings good at interpreting and which charts do we struggle with. So they showed their participants a series of lines and bars and shapes that encoded numbers. And we call these options up on the screen elementary perceptual tasks. And they measured how good the participants were at deciphering each of these tasks. And they ranked them from the tasks that we're worst at to the tasks that we're best at. And we have some clear winners. Human beings are best at perceiving numbers encoded by length and position. They're our go-to choices for human-friendly chart types. So let's visualize our personality test data using position. Not much of an improvement, right? So this is called a radar chart. And it uses position, but it uses it randomly. There's no reason that these personality dimensions should appear in the particular order they do, or why they should form a pentagon. It pains me to say it, but if you actually take a personality test, you're very likely to see a mess of a chart like this. This chart is becoming popular. Consultants are even using it. So why does this train wreck of a chart proliferate? Well, it could be that the consultants want to distract you from how much they're charging, but it could also be that this chart does look kind of interesting. I have to admit. Some people would even use the most dangerous word in the English language when it comes to data visualization to describe this chart. And that word is cool. Whenever I hear this word, whenever someone runs up and tells me, Dom, I've got this cool new chart I want you to see, I shudder in fear. Because I'm about to see a disgrace of a chart like this. Once again, this chart uses position randomly, and it uses area, which we've seen from our pie chart example, is not a good way to encode numeric values. And we can make it even worse. We can make the bubbles dance around and light up. Modern software packages allow us to do more new and exciting things with data visualization than ever before. But just because we can, doesn't mean we should. So I want to convince you that simpler is better. And I want to come back to a simple human-friendly chart type that uses position. And now we're going to use position properly. We're going to align these positions that show our values on a common scale. We're going to change our data to a dot plot. Suddenly, the insights are immediately obvious. I'm much more extroverted than my friend, and she's much more agreeable. I'm not the most agreeable person. And on the other personality dimensions, we're almost the same, which is maybe why we're friends. I want to move on to the next key to effective data storytelling, which is to be a ruthless minimalist. And to explain this concept, I want to use a personal example. So I've been in a relationship for about 2 years now. And it's often around this time that your partner starts to ask about some of your previous relationships. So I did what any good data storyteller would do, and I put together a chart. So here it is. And so, thank you. I'm going to need your help to fix up this chart. And so I wouldn't blame her if she left me on the spot, just for the bad chart design here. So we're going to fix this up. This chart shows on the x-axis my age in years, and I've estimated the intensity of some of these past relationships over time. But before my audience, which is my current girlfriend, can understand what's going on with this chart and understand my message, we need to remove all these distracting components, which we call chart junk. Let's start with the worst component first, this background color, which serves no purpose. Now, this chart's just an estimate I put together. We don't need a huge degree of precision. So let's get rid of the grid lines. And we can also get rid of this chart title.
At age 25, he was having two simultaneously.
Now there's one more piece, chart junk, that needs to be eliminated from this.
See this 225 here.
What it is. I'm going to go against what we might have learned in school and university and say that every chart does not need a legend. This legend is forcing our audience to do work. Our eyes have to track up and down between the legend and the series labels, and we have to hold the series labels in our short-term memory. It's diverting our attention from the message of the chart. Fortunately, there's a better way. Human beings naturally perceive objects that are close together as belonging together. And we can take advantage of this and just label our series directly by putting the labels close to the series. And we can further reinforce and strengthen this connection by using similarity of color. So let's do that. Now this chart's still a little busy for my liking. We've got a lot of color here, and color is a devastatingly effective way to focus attention in data storytelling. And because it's so effective, we want to use it sparingly. So I'm going to push everything to gray for now, to create a blank canvas for storytelling. And that leads us into our third and final key principle of data storytelling, which is that everything we put in front of our audience needs to contribute to a clear key takeaway that our audience cares about. So with our all grey blank canvas, let's take our audience through a story and highlight the pieces of this story one at a time. So we start with my lackluster first attempt at dating. Consistently pretty low intensity here. Let's call this a practice. And in my mid-20s, I thought I could handle 2 relationships at once. The data shows this was not an effective strategy, with both of them pretty quickly plummeting down towards 0. And now we've got the most dangerous and volatile territory of all, the ups and downs of this almost marriage. And my current girlfriend might notice that the peak intensity of this relationship is higher than the highest peak of my relationship with her. So I need to add a little bit of reassurance here and just let her know that I no longer speak with men. And of course, their names have been changed in this example. So after that ordeal, we have the recovery period. I estimated the intensity of these relationships on quarterly intervals. So sadly, none of these dots made it into a line. And finally, we've got my current relationship with a forecast of strong growth expected to continue into the future. Now, I promised you at the start of this talk that I was going to convince you that data storytelling can change the world and can even save lives. Now, this chart might not even be good enough to save my relationship. So I want to show you one of the most profound examples of effective data storytelling in history. And to do that, we have to go back to 1854 in the crowded and swollen streets of Soho in central London. Back then, there had been a dramatic and rapid outbreak of deadly cholera in a street called Broad Street. And the prevailing view amongst physicians at the time was that cholera was caused by a mysterious foul stench in the air, a force they called miasma. So they were wrong. But there was one physician that dissented, a man called John Snow. And John Snow believed that cholera was being transmitted via drinking water. And he shared his theory with his colleagues. And they replied, "You know nothing, John Snow." And so John Snow collected some data. He collected data on the locations, the exact addresses of every cholera case in London. And he marked down the locations where they had occurred, and the more deaths there were at each location, the larger these black bars that I'll show you grew. And we can see when we zoom in on the Broad Street pump that we have the highest concentration of cases around this pump. And back in those days, people would walk to their closest pump to gather water. So what we see when we look at some pumps a little bit further from the Broad Street pump is the cases start to drop off. And when we go very far from the Broad Street pump, where no one could possibly be walking there, the cholera cases disappear entirely. So John Snow took his findings to the local parish commission, and they finally said, "You know something, John Snow." And they agreed to remove the handle from the Broad Street pump. And within the day, the deaths had stopped. Now, the epidemic had already peaked by this point, so we don't know how many lives were saved. But John Snow's contribution would go on to shape the field of epidemiology and make a massive contribution to the germ theory of disease. John Snow was able to change the world with data storytelling because he had a simple, human-friendly chart that used length to encode his values. He was a ruthless minimalist, maybe because that back then he didn't have the choice to add chart jump to his visualizations. And he had a clear and powerful takeaway that his audience cared about. And I want to convince you that you too can change the world and tell impactful stories with data. And all you need at your disposal is the simple tools that were available back in 1854.
Yeah. So you got a few ideas from this video, right? Okay. You got ideas how his relationship is varying over the years. Okay. So how over the time, if he is having two at the same time, it did not work out. It collapsed to zero, right? But the last one was very nice. Okay. The last one was very nice and very realistic idea where they found the reason behind occurrence of cholera, right? So what they did is they found a map. Okay. And they found the spots where the water pump is, and they collected where the live cases were, where the positive cases are, right? And due to that, they saw that people, when they are using that hand pump regularly, most affected area is that. Whereas other parts of the map where people normally don't go there because it's the end part of the village or something like that, their cholera did not spread. Okay. So then he got an idea, at least one spark in his mind, that cholera is linked to the water. Okay, that was what many people could not find, and deaths were occurring, right? So that only that one spark can lead to further developments, like water quality needs to be checked. But before that, there are so many parameters that you cannot recognize, right? There is temperature, there might be virus from the fruits, there might be virus from the vegetables, right? There might be virus from people transmitting. Okay, so how many they can check? But apart from all this, they just boiled it down only through this visualization. It just came to one single relationship, that is water and cholera. Okay, so you can see how powerful this can be. So this was a really good video, I suppose. Okay, which can give you an idea of what storytelling is. Okay, you saw how storytelling of that map and here was able to transmit the knowledge from the professor level, who the scientist, to common man, those who were handling the village. Okay, they did not agree to him first, but after they understood the facts and all, as he communicated to him properly or story told the data properly, they could understand, and then they agreed with him. Okay, so this is all about data storytelling. Okay, we'll have a break. Okay, and we will meet after some time. There we will start with data warehouse.